Hello everyone, welcome back to lesson 30 for BC Calculus. This lesson's been all about volume thus far. The first two videos we talked about volume of cross sections. The third video we talked about volume of a disc. And in this video we're going to talk about volume of a washer. I want you guys to know that so far our pattern has been a number times the integral of the area of whatever we're actually rotating, and then our dx or our dy. This is no different. The only difference about this is that when we rotate this around a line, we're actually going to create ourselves a little hole. So let me go ahead and talk about how to do this question. And again, it's very similar to the one we just did with our disk. So question number 8 says, find the volume of a solid generated by revolving the region bounded by the parabola y equals x squared, which you guys can see right here, and the parabola y squared equals 8x, which you guys see right here. You guys, most of these questions are calculator. So you could graph this to see kind of what's going on with this problem. And then we're going to rotate this around the x-axis. So I'm going to say, as I said in the previous video, that if I'm rotating around the x-axis, I like to go ahead and draw a little arrow. So I'm rotating this thing around the x-axis. And then since this is a horizontal line, then I know that I'm going to be in terms of x. Remember, any horizontal line is going to be in terms of x. I also want to notice that if I draw myself a rectangle, the rectangle is actually not touching the line of rotation. And it doesn't have to be the x-axis. I could actually ask to rotate around the line y equals -1. So they're not touching. So that's going to let you know that you're actually going to have what you see here, which is a washer. If I start rotating this around this axis, I'm going to create a hole. I'm going to create a hole here. So you guys can see that it's going to come like this. Again, I'm so bad with drawings, and I'm so sorry about this. So if I start rotating this thing around, I'm actually going to create myself like a little funnel looking thing, as you guys can see here in this much nicer picture. So what we've talked about in the previous examples is that when you do that, you want to find the area of the shape that you're actually rotating. Well, if you look at this, and I'm going to redraw it over here, I've actually got a washer. I have myself a big circle, which is clearly this, minus my little circle. If I find the area of the shaded region right here, and this is again some geometry of our little donut that you see, then I would have to find the area of the big circle and subtract the area of the small circle. Well, the radius of, the area of the circle is just pi r squared. So the radius of the big circle is going to be what you see right here. Right, so this is going to be our r. And so if you guys want to look at over here, the radius, the big R, is going to be right here. And I call this big R because this is the big circle. So the radius is going to be from the top of my circle to the center. Again, that's what a radius is. So going back to what we learned in the previous lessons is that if I want to find this distance, I want the rectangle that looks like this for the big R. Well, we've learned that that's going to be the top function, which is going to be the square root of x squared. So big R is going to be this green line. And so it's going to be the square root of 8x minus our bottom curve, where our bottom curve is actually, in this particular example, our axis of rotation, which is going to be the x-axis, where the x-axis is actually the equation y equals 0. So big R is going to be the square root of 8x minus 0. Little r is going to be this little guy. All right, so actually let me erase this. So let's go ahead and get rid of all of this for us. And let's talk about little r. Well, little r is going to be from here, the curve that's closest to the axis of rotation, to the axis of rotation. So it's going to be this little guy right here. And if I'm going to keep getting consistency, it's going to be this side right here. So little r is going to be the curve that's the closest to the axis of rotation. And again, it's always top minus bottom. So the curve closest to the axis of rotation is going to be x squared. So we're going to do x squared minus 0. So we have our big R and we have our little r, which is actually pretty awesome for this. So remember again with volume that it's going to be the integration of our area. So again, our area of our circle is going to be pi r squared. So we have enough information to start writing out our integral for this. So we're going to do the volume, and I'm going to just separate them for us for right now. And so we're going to integrate this just like before. So if we're in terms of x, it's going to be our left bound and our right bound. And so we're going to integrate from 0 to 2. Now, if you didn't have a graphing calculator, or you didn't have time to graph this, what you could do is actually set these two things equal to each other. So you can get x squared is equal to the square root of 8x. Voila, here it is. I just wrote it for you guys. So you set them equal to each other. Again, this video is not for algebra, so you set them equal to each other, and then you get down to the point where, okay, x is equal to 0 and 2. So we're able to do it algebraically. So if you want to know their intersection point, by all means do that. So from 0 to 2. So we're going to go ahead and first of all do our big R. So remember, it's going to be pi, and then this is our radius, and remember, it's pi r squared. So we're going to take the square root of 8x, and we're going to square it. I've just dropped the 0. All right, and we're going to do examples where it's not the axis in a little bit of time. And so we're going to go ahead and do dx for this one, and so that's going to give us the area of our actual rectangle. And then we're going to subtract from 0 to 2 our small one. So this is going to end up being pi, and our radius is going to be end up x squared dx. All right. Now, that is a correct way of doing the problem, but you guys know there is a shortcut. So what we can actually do here is, if we want to find the volume of a washer, well, the first thing they both have in common is a pi. And we talked about that also when we're talking about disk. So if you do a washer or a disk, you can always pull out a pi. And then we're going to integrate, well, they're both integrated from 0 to 2, which is not going to change. We can go ahead and have the square root of 8x quantity squared. And then we can go ahead and do minus the x squared, and then we have the dx. So this is usually what you guys are going to end up showing me as an easy way of setting these problems up. And we're going to do quite a few of these problems. Like I said, this is the very first one where one of our axis rotation ends up being the axis. And then, when all is said and done, and you plug this into your graphing calculator, because this is what you're going to do, you're going to get that the volume is approximately 30.159. And so after all these videos are said and done, I'm going to give you guys a review of everything that I've done. So let's continue on with example number 9, and this one is going to be a semicircle region bounded by x equals. It's really awesome when they're giving us the function as x equals, so most likely it's going to be in terms of y. But we're given the function, all right, x is equal to the square root of 4 minus y squared, so it's a circle. If you actually were to solve this out, you get y squared plus x squared is equal to 4. And so we have a circle with a radius of 2. But this equation, x equals the square root of 4 minus y squared, actually gives us the right hemisphere of it. All right? And then we're also bounded by the y-axis. And we want to revolve this around the line x equals -1. So this one's actually a lot more interesting. So we're going to revolve this around not the axis, because if we were going to revolve it around the axis, then we would actually just simply have a disk. Well, we're going to revolve around this line right here. And so again, this visual is really pretty for you guys. You can see that this piece right here ends up being this curve right here, and then revolving it around the line x equals 1. So if we have another little line right here, it will create ourselves this nice little washer that you guys see. So we want to set up the integral to represent its volume. The first thing we're going to notice is that I'm rotating around the line x equals -1. This is a vertical line. All vertical lines is going to be in terms of y. So we're going to be dy here. We're going to do dy here. Now I'm going to go ahead and show you guys this problem by just showing you this simple shortcut, because I want to say to you that when we're finding this washer, volume is going to be equal to, I'm going to erase this in a second, and I will come back and talk about this in another video, but it's going to be your pi, integration from a to b. It's always going to be your big R squared minus your little r squared dx or dy. So one of these problems. So if we can find what our big R is and our little r, then we can just solve it like this, which is exactly what I did in example number 8. Okay, so let's go ahead and start doing that. Volume is equal to, well, I'm going to go ahead and pull out the pi, because we can always pull out the pi. And then we want to integrate this from our lower y bound to our higher y bound. All right, so we're going to -2 to 2. And what we have to do is find our big R and our little r. And so this is what's going to take a little bit of practice to do. So big R is going to be this distance right here. It's going to be the radius of this larger circle. So it's going to be the curve that's going to be to the right, which is going to be this function, and then it's going to be minus the curve that's actually over here. It's going to always be our curve to the right minus our axis of rotation. Now, if the axis of rotation was over here, then it's always right minus left is what I should say. So our curve is actually to the right of our actual axis of rotation. So our big R is going to be the distance of our curve minus our axis of rotation. Well, our curve is going to be the square root of 4 minus y squared. That's exactly what you see here. It's going to be the function x equals this function. Well, we're subtracting the axis of rotation. So we need to subtract the function x equals -1. And that's what our big R is going to be, because that's the distance that we have from here all the way to here. And another way to think about this, ladies and gentlemen, that I tell my students is that you could also think about it like this. You could say, all right, this distance here is going to be the square root of 4 minus y squared minus 0. All right, but we have to then add the distance from here to here. Well, this distance is from 0 to 1, so we have to add an additional 1, which is what's going to end up happening right here, right? We're going to go ahead and add this 1 to it. I think it's much easier to just go ahead and do our right-hand curve minus our axis of rotation and call it a day. So this is what our big R is going to be. So I'm going to go ahead and write out what that is. So our big R is going to be the square root of 4 minus y squared plus 1, and we have to square it. Because remember, again, the area of a circle is going to be the radius squared. Again, we've already pulled out the pi. And so now what I can do is find our little r. And so our little r is going to be this little guy, right? It's just going to be this system right here. It's going to be the curve that's the closest to our axis of rotation, all right, that makes up our shaded region, and then obviously our axis of rotation. Again, it's always right minus left. So this function right here is x equals 0, and so we're going to do 0 minus a -1. And again, ladies and gentlemen, you guys can see that this is actually just simply going to be 1. All right, so our little r is going to be 1. So then over here, we're going to do minus 1 squared. And then everything is in terms of y, so this is going to end up being dy. And so this is how you set this problem up. And then we're going to get the volume of this is going to be 72.989. All right. Now, in the next video, we're going to do a lot of review. So I'm going to do one question, 4 parts. That's going to give you everything that hopefully you will be okay with in the next video. So this was just an idea of how to do washers. So I will see you guys in the next video.